Okay, so I have to say this again so it's recorded. Sorry. So y less than or equal to 1/3. I have to write the equation. I'm not changing the inequality into an equation, but I need to graph the equation first. So when x is 0, y is 0, I get this. I make another point. X equals 3, y equals 1. I plotted the points and I drew the line. I drew the line as a solid line because the equal symbol is in the symbol of the inequality. Okay, so now I have to use any point I like. I like this point, 0, 10. And I'm checking the region above. Okay, 0, 10. Is 10 less than or equal to 0? No. So I have to choose the opposite. All this area, all these points, make up y less than or equal to 1/3 x. This one is y greater than 1/3 x. Who cares? This is not what we need. We need this. And that's how we solve an inequality. This is the only way, by graphing it. So if I'm asked to solve this inequality, I'm actually asked to graph it. There is no other way. I can't explain to you and put it in words and say, hey, it's the area below the graph of the equation. No. You have to graph the equation. You have to check with a point. It doesn't matter which area you pick. For example, if you had picked 0, negative 10, you would have gotten the true statement. How come? 0, negative 10. Negative 10 is indeed less than or equal to 0. That's why we shaded this area. That is the correct solution, not this. So there is no other way of explaining or showing the solution, but by graphing it. Okay, so let's go back. Now we're ready to look at systems. 2 or more conditions put together. Okay. We can look at others. There are other examples. We can look at other examples for single inequalities. And then we can look at systems. So let's continue. 11 through 26, let's choose another example or two, because they're all different. This is different, this is different, this is different, they're all different. This is different, this is different. They're all different types of functions or curves. So anyone would like to choose something else? If not, I will.
We try 15.
You said 15? Of course.
Yes.
Good one. Very good one. So let's continue 15. Which page am I on? I'm on 9. Okay. And 15. And in 15 we have x squared plus y squared greater than 25. Perfect. Same thing, the same routine, always, always, always. X squared plus y squared equals 25. What type of equation is this? We graphed this many times. We know what it represents. What does it represent? We've seen this before. We graphed it too. And even on the previous test, not this test 4, but previous, we graphed this. What is it? Anyone remembers? Anyone? It's a circle centered at the origin. And can anyone tell us the radius?
5.
Indeed. Good. So I'm ready to graph. Stop. There is no equal symbol. I cannot draw the circle as a solid line. It has to be a dashed line. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is the equation of x squared plus y squared equals 25. It does not pass through the origin. I'm going to use the origin. 0, 0. 0 greater than 25? No. So I cannot choose the area inside because now the circle divides the plane into two pieces, the inner and the outer. So I have to choose the outer. This contains all the points that verify this inequality. It's the only way to solve it, by graphing it. Good pick. Good. Anything else? Okay, it's my turn to pick. So I will pick 20. In 20 we have y less than x squared minus 9. The equation y equals x squared minus 9. What graph is this? What function is it? We graphed this too in the past. We used transformations on it, many different situations. So how do I graph x squared minus 9? What type of function is it? How do I graph it? Anyone remembers x squared minus 9? Please, anybody?
It will be x minus 3 and x plus 3.
Good, those would be the x-intercepts. But it's quadratic, it's x squared, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Solid curve? No, because there is no equal symbol. So here it is. It's a parabola. It's a quadratic function. We graphed it several times this semester. So this is y equals x squared minus 9. It divides the entire plane into two pieces, the outer and the inner. I picked the origin, so I'm checking the inner. So 0, 0. 0 less than negative 9? No. Again, I cannot pick the inner where the origin is. I have to pick the outer. So this is y less than x squared minus 9. All the points here verify this inequality. All the points inside do not. Good. Let's also look at 24. Again, without redoing each and every problem we covered in class, chances are that you may not remember. Okay, y less than or equal to 3 to the x. Good. Anyone remembers how to graph y equals 3 to the x? We had it on this previous test, test 4. Anyone remembers? What type of function is it? anything. Anyone remembers what type of function it is? At least the type.
Would it be a logarithmic?
It's exponential, right? The power is the exponent. The power is the variable, exponential. And it's increasing on all its domain because the base is greater than 1. Do I graph it as a solid line? Yes. So what's the difference? I keep saying solid or not solid. What does this mean? It means that the points on the circle are not part of the solution because there is no equal symbol. The points on the parabola are not part of the shaded area, which is the solution, because there is no equal symbol. But now, because there is equal symbol, and because I am going to graph 3 to the x like this, y equals 3 to the x, points on this curve will be part of the solution. So now this graph divides the plane into 2 regions, above and below. I will check the below with 0, 0. Let's see what happens. 0 less than or equal to 1. True. That's true. 3 to 0 is 1, and this is 0. So I will choose this area, including points on the line because of the equal symbol. So y less than or equal to 3 to the x. Now, the same thing happens with systems. And what's the difference? Well, there is more than one condition. So now we are choosing from 27 all the way to 62. So let's practice how to solve systems now. We haven't solved any yet. We only looked at single inequalities. So we understand how this works, and now we are ready for systems. Anyone would like to pick, or I will?
We start with 29.
Absolutely. Good pick. Let's start with 29. 2x minus 5y less than or equal to 10, and 3x minus 2y greater than 6. Perfect. Okay. So for now, we are going to address the first inequality exactly as we did before, as if the second one is not even there. So 2x minus 5y equals 10. When x is 0, y is negative 2. So 0, negative 2. When y is 0, x is 5. So 5 comma 0. I will graph the first equation. 0, negative 2, 5, 0. Solid or not? Solid, because the equal symbol is there. Good. Oops. This is 2x minus 5y equals 10. I will pick the origin. I see that the line divides the plane into 2 pieces, below and above. I check with 0, 0, so I'm checking the above. If it's true, I choose it. If it's not, I choose the opposite. So 0, 0 less than or equal to 10, yes? Yes, that's true. Okay. All this territory, including points on the line, represent solutions to 2x minus 5y less than or equal to 10. I continue with the second equation. 3x minus 2y equals 6. I repeat the whole thing. When x is 0, y is negative 3, So 0, negative 3. When x is 0, when y is 0 now, when y is 0, x is 2. 2 comma 0. I have the points. I go back to the graph. So 2, 0. And 0, negative 3. Solid? No. So this is 3x minus 2y equals 6. It divides the plane into two pieces, this and this, and I will check with the origin. 0 greater than 6? No. 0, 0 greater than 6? No. So this is 3x minus 2y greater than 6. And now because I want both conditions, it's a system. I want just the territory that solves both at the same time, not just one or the other. So now I see this is the one territory and this is the other territory. And I see this is the intersection. That's all I need. I only need this territory. So all points on this line, not points on this line, but everything else. Not points on the line, but everything else. This represents solutions to both at the same time. Everything on this line, every point in between those two, but not points on this line because there is no equal symbol here. That's the only way we can graph and solve a system of inequalities. Any questions? Okay. We are ready to practice anything else you want. If you don't choose, I will. Okay, I will choose 49. Anybody has any questions, please? Any questions so far? X squared plus y squared greater than 1. X squared plus y squared less than 16. Okay. Can anyone tell us what these represent? We just looked at an example a few minutes ago. What are they?
Are these circles?
Yes, yes, with the center at the origin because there is nothing subtracted from x and y. And what is the radius in the first and what is the radius in the second?
1,
Yes, perfect. And then the other one?
4.
That's it. Awesome. Good. I'm going to graph the first one. 1, 1, 1, 1. Stop. Solid or not? Not. Good. I'm going to graph the second one. 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4. Before we do that, sorry, we have to solve the inequality first. Sorry. Okay, So this circle divides the plane into two pieces, around it and inside. I'm going to choose the origin. 0 greater than 1. No, 0 is not greater than 1. So I cannot choose the inside. I have to choose the outside. So this is x squared plus y squared greater than 1. Now, only now, I'm ready for the other circle. Solid? No. Meaning the points on the circle will not be part of the solution. Now, 0, 0. So this big circle divides the plane into two pieces, the inside and the outside. So I'm choosing to check the inside with 0, 0. 0 less than 16, yes. So this inside is x squared plus y squared less than 16. Now, I have to shade in the gray area with the orange area. And what do I get? I get points right between the two circles, but no point on the circle. So I get this, I get this, I get this, not points on the circles. What is this? Both at the same time. It's the only way to present the solution.